Hello everyone. In this video, we'll be studying about the topic functions, some special kind of functions. So before we go to the topic functions, let's go to the basics of it and then move on to function. So let's begin. So the first thing we need to understand is what is the partition product. Let's take two non-empty sets. Say A is 1, 2 and B is 3, 4. Now A and B may have same elements or one or more element similar or in common. I have taken different ones here. Partition product is written as A cross B, and when we are finding A cross B, we need to relate element of A to B. So 1, 3 and 1, 4. Every element of A to every element of B. And what would be B cross A? In this case, we will start with element of B and go to A. 3, 1, 3, 2, 4, 1, and 4, 2. So as you see, the order of the element is important here. In A cross B, if we write in general, it is x, y such that first element belongs to the first set and second element belongs to the second set. And every element should be related. So if number of elements in A cross B would be number of elements in A into number of elements in B. Now, every subset of this A cross B is a relation. So what are the subsets of this null set? Another subset will be 1, 3, 1, 4, 2, 3, 2, 4. So we have written the singleton subsets. Now we can write subsets with 2 elements. Then we would write the subset with 3 elements. Subset with 4 elements. There are more elements. There are more subsets with 2 elements and 3 elements. I have just written one example of each. So if we look at how many subsets are possible, we know the formula for finding subset is 2 raised to n. Now here n means number of elements in A cross B. So it would be n of A into n of B. Looking for this particular example, number of elements would be 2 raised to 2 into 2. That is 16 subsets we will get. And all the 16 subsets are relations. This is empty relation or null relation, and this is universal relation. So since we know what is a relation now, we can move on to functions. If you want to study this in detail, I have uploaded another video especially on relation and types of relation. You will find the description below to study about it. So we know now that relation is a subset of A cross B, any subset of A cross B. The example which we had taken, we had 16 subsets and all the 16 subsets are relation. However, function is also a relation, but it has some conditions that apply to it. What are those conditions? The first thing is, every element of A should be associated. The next, it should be associated uniquely. So now, what do we mean by these two things? Let's say we have taken a subset of A cross B as 1, 3. Now let's take an example earlier. We know that A is 1, 2 and B was taken as 3, 4. So you see that 1 is associated to 3, but 2 did not get any association. So this is not a function. Yes, if we were to take an example, say 1, 3 and 2, 3. This is good because 1 is associated, 2 is associated. So what we said is every element of A should be associated, and the next thing is it should be associated to unique element. Some elements of B may not be associated, is good, this is a function. By unique association, we mean that if 1 is associated to 3, then 1 should not get any other number like this. Suppose if we take this subset, 1, 3 and 1, 4, this is not a function. So by function, we mean that every element should be associated and it should have only one value. Like 1 is related to 3, good. 2 is related to 3, fine. Can also be like this, 1 related to 3, 2 related to 4. So all elements B of B may or may not be associated. But every element of A should be associated, and that also in a particular way. That is, if 1 goes to 3, 1 cannot go to any other number. So this is what we mean by a function. Now let's see the various special types of functions. So I have written the same example here to see how we write a relation. Like suppose R is a relation, I have taken an example, can be written in this form, an ordered pair, can also be written as 1 related to 3 and 1 related to 4. And the function, again I have taken one example, can be written like this. That is 1 is related to 3, 2 is related to 4, but because it is a function, I have called it f. Can also be written as f of 1 is 3 and f of 2 is 4. So we mean that 1 is related to 3 here and 2 to 4. So in general, we can write f of x is equal to y. Now where does this x come from? X comes from the first set. X belongs to A and y belongs to B. In here, A is called the domain and B is called the codomain. And as we said, since all elements of B may not be associated, so those elements which are associated, when put in a set, is called range. Okay, so these are some terms which we need to know. Like the first one is the first set. Suppose we are finding a relation. Suppose we are finding a function from A on A cross B, then A is the domain, B is the codomain. Those elements which are related, like 3 and 4, that's the range. So we can write range of F is 3, 4. In case if we were to take this example, then the range of this function will become 3. So range is only those elements which are related and those of the set B. Because we are looking for a function on A cross B. And it will be written as f from A to B such that fx is equal to y. X is called the pre-range and y is called the image. These are those functions which we will be using very frequently. So the first one is linear function. So as we wrote earlier, we write f is from R to R. That means the domain is R and the codomain is also R. Now let's see what is the function. It is defined as fx is equal to ax plus b, where a and b are real numbers and a is not equal to 0. so that we have x as the variable, and since this degree is 1, it's a linear function. Let's take one particular example of this kind. Suppose if we take fx is equal to 3x plus 2, we know that fx is y, and when we have written this, we immediately realize it is the equation of y. And how do we find the value? Let's take different values of x and find the values of y the same. Now let's trace the graph of this function. So I have taken a few values here. Let's plot the graph of this. When x is 0, y is 2. When x is 1, y is 5. And when x is minus 1, y is minus 1. We'll join these points to find what kind of a line it is. On joining the points, we get this line, which is y is equal to 3x plus 2, or now we can call it fx is equal to 3x plus 2. So an observation will find that what values will y take, which will take all real numbers, and that is why the range is R. Now let's go to the next one. Now, identity function is a type of linear function. The thing is, over here, earlier we had taken ax plus b. Now our a value is 1 and b value is 0. That makes the function, we know the domain and codomain is real numbers. So fx is equal to x. Why is it called identity function? Because the preimage and the image both are same, identity function. So let's try to plot this again and take a few values. We have the values here. Let's plot the graph. For minus 1, it's minus 1. 0 is 0. And the 1 it is 1. Join the points. And once again you will see that all real numbers will be associated, and hence the range is, in this case, we need to know the domain, the codomain, the range, and the graph. For all the special functions. Special functions means those functions which we are going to use again and again. So polynomial function is basically what we studied in class 10 or the earlier classes. This is a polynomial expression wherein we write the image also. So various type of polynomial functions we have. Like we have if x is equal to, if we take a simple one like x squared, if x can be x cubed, can also be x raised to 4 plus 2x cubed plus 7. Any of this kind, any polynomial expression can be written in terms of function. So every polynomial function will have a different graph. We do not have a general graph like the identity function. For example, if we take x squared and try to plot it, let's see what we get. So I have taken a few values for the function fx is x squared and fx is equal to x cubed. Now let's see what kind of graph do we get. As we see for 0 it is 0, or minus 2, the value is 4, for minus 1. So let's join these points, and it is a parabola. Fx equal to x squared is a parabola. Curve is like this. Let's see for fx equal to x squared is a parabola. Now let's see for fx equal to x cubed. So for minus 2, the value is minus 8, somewhere down here. For minus 1, it is minus 1. 0. For 1, it is 1. 2, it is 8. So we have a graph, something like this. Go down. So this is the graph of x cubed. So every polynomial function will have a different range. Like in here, we have only positive real numbers, not negative actually. In this case, we have only non-negative real numbers as our range. In this, we have all real numbers as range. So range will depend on what kind of polynomial function it is. In the earlier cases, we had a fixed range. The next one is a rational function, which is polynomial function upon polynomial function. If you have noticed, I have not written f from R to R in this case because it depends now the domain may also not be fixed. It depends on the function. Suppose that the function is x plus 1 upon x plus 2. Now, we cannot take x equal to minus 2. So we write x not equal to minus 2 because in that case the denominator will become 0. The function will not be defined. So our domain here is r minus minus 2. Also, the range will depend on what values of y will be associated. What values of the codomain? The codomains are different codomains are. And to find the range, we can take this value as y and find x from here. So we will cross multiply this. Let's bring the x term on the left side. This is how we find the range of function. One way of doing it. So we obtain x as 2y minus 1 upon 1 minus 1. Now if y is 1, then this x value becomes undefined. So y should not be equal to 1. That means what are the range values? Range will be all real numbers except 1. But for this one, like the domains are minus 2, minus 2. Now the domain also changes with every function in the case of rational functions. What is a rational function? It's a polynomial function upon polynomial function. Since the denominator has to be non-zero, the domain will depend on that, and the range will depend on which values of x are not allowed. Like x is equal to 1 minus. The range will depend on which values of y are not allowed for x to be defined. In this case, like 1 minus y, so y is not equal to 1. And so the range is r minus 1. The next one is modulus function, which is defined as f is a function from real numbers to real numbers. That means the domains are, the codomains also are. Fx is equal to modulus x. Now, by modulus x, we know that the negative numbers should also become positive. And obviously, the positive numbers are going to remain positive. So we need to redefine this, and we can write minus x for less than 0. That means when we put, suppose if it is minus 3, we need to put one more negative sign so that the answer will become positive. That's why we write minus x to less than 0 and x for greater than or equal to 0. Whatever the value, same should come. Negative, put one more minus sign so that it becomes positive. So we can write it as modulus x, or we can also write it as minus x for like x less than 0 and x for x greater than or equal to 0. Okay, so let's see the graph. So let's plot the graph. For minus 2, the value is 2. For minus 1, the value is 1. For 0, it is 0. For 1, it is 1. And for 2, it is 2. So we are going to get positive values and same values here. So we are going to get positive values for every value, and this would be the graph. So V-shaped graph, vertex at x equal to 0. This is a special type of function. We may have different kind of modulus functions, like suppose fx is equal to modulus x plus 1. So it will again be a V-shaped function, but now its value will be 0 at minus 1. So for modulus x plus 1, the vertex will be at -1, or it is also called the critical point, where the function is going to change the way it goes, like from minus infinity, if we keep on coming, it will go to 0 and then it will go on the other side. So it is the point where it is going to become 0, where the vertex is similar to this one, just shifted on the right side. So that is the modulus function. For different modulus functions, you will get different graphs, but yes, the range is always going to be non-negative real numbers, that is closed open interval 0 to 20. So the next one is a signum function, and it is particularly defined in this way. That is, for all negative numbers, it is -1. For 0, it's 0, and for positive numbers, it is 1. So this is a special function which has applications in higher uh, studies. We just need to know what kind of function it is, what is its range, and how would its graph look. In all these examples or in all these functions, I have taken only integral values, but that doesn't mean that these are the only values. You have all different kind of real numbers in here, but since it's easier to plot with integral values, I've taken up integral values. So over here, for -2, the value is -1. For -1, it is -1, and all the other real numbers in between also have the answer as -1. So you would get a line like this here. For 0, the answer is 0. And for every other number after 0, say 0.01 or 0.001 or whatever, the value is 1. Everywhere here we have 1. So we'll get a graph of this kind, and we see that the range is only this values, -1, 0, and 1. The next one is greatest integer function, also known as floor function. It is a type of a step function. Let's see why it is called a step function or a floor function. It is defined as the greatest integer less than or equal to x. Now, what do we mean by this? When we are taking any integral value, the answer will be that same integer. But if we take a decimal value, 1.01, for example, let's understand this with a number line. We said greatest integer less than or equal to x. So x is 1.01, somewhere over here. The integers smaller than this are all of this. The greatest one among them is 1. So that's your answer. Okay, so any value between 1 and 2 will give the value as 1. Any value between 2 and 3 will give you, because all those integers are smaller than say 2.1, 2.2, 2. Whatever, up till 3. So it will be 2, the greatest integer. So if you look at this on the number line, it's very simple. It's the nearest left integer. So suppose you're looking for 0.5, the nearest left integer is 0. If you're looking for -0.5, the nearest left integer is -1. That is your answer for this greatest integer function. So we'll try to redefine this function. And if you take an integral value n, so all values between n minus 1 and n, including n minus 1, will have answer n minus 1. Every integer between this will have nearest left one or the greatest integer less than or equal to n. And from n onwards, it will be n. So this is how we can redefine it. Let's see how to plot the graph. So when we take a value between -2 and -1, between -2 and -1, x value, x belongs to this, then the answer is going to be -2. But as soon as we come to -1, the answer is going to be -1. So that's why we put an open circle here. In the previous graph also we put an open circle to show that the value doesn't belong here, it goes up here. For every value between -1 and 0, the answer will be -1. But as soon as we go to 0, the answer goes to 0. All values between 0 and 1, 0.1 answer 0, 0.5 answer 0. For 1, the answer goes to 1, and so on. So that's why it is also called a step function, because it is like steps. Now, what is the range? Only integral values. So the range is Z. The domain is R, the codomain is R, and the range is only integral values, that is Z. And since we had values on the left side or smaller values than X, it was also called floor function, floor values. The next one is a constant function, which is a function from R to R, where fx is defined as C. Now, the function depends on what C value is. For example, if fx equal to 2, then for whatever x value you take, it is going to be, the image is going to be 2. It's like constant polynomial. So, for different values of x, for -1, it is true. 0, it is true. For 1, it is true. You can take any real numbers, the answer is going to be 2. For -1, 2. 0, 1. So we get a horizontal line because it is of the line y is equal to 2, which is the horizontal line. And the answer is always 2 in this case. So in general, the answer will always be C. It will depend on what C value is, whether it's 3 by 2, whether it's -1, whatever. So the range of this function will be singleton set C. Domain R, codomain R, and range singleton set C. So I will put a link below for you to look for all the domain, codomain, and range of the special types of functions. In the next video, we'll be taking up the types of function, that is one-one function, onto function, and so on. Hope you did understand. So do like the video, share it, and hit the bell icon. See you in the next one.